In this video, you'll learn how to find the sum of the angles in a polygon. We already know how to find the sum of the angles in a triangle, which is the simplest polygon, a polygon with 3 sides. Here we're going to take a look at these 3 polygons, a 4-sided polygon called a quadrilateral, a 5-sided polygon called a pentagon, and a 6-sided polygon called a hexagon. And again, our goal is going to be to find the sum of all the angles in the polygon. So in this 5-sided polygon, we're going to find the sum of these 4 different angles. So what we're going to do first, as we do this, is we're going to draw something called a diagonal. Now a diagonal connects one vertex to another vertex. So if I start at this corner and draw all the diagonals that I possibly can, the only diagonal I can draw is this one here. So that particular quadrilateral has one diagonal, and you'll find that no matter how you draw a 4-sided figure, it will always have one diagonal. For the pentagon, if I use this as my point, here would be one diagonal and a second diagonal. All pentagons are going to have 2 diagonals. And if I look at the hexagon and say I choose this point, here's going to be one diagonal, 2 diagonals, 3 diagonals. All hexagons are going to have a total of 3 diagonals. Now notice, back at the quadrilateral, that the diagonals separated it into 2 triangles. The pentagon was made into 3 triangles, and the hexagon was made into 4 triangles. So we can find the sum of the angles in the quadrilateral. There are 2 triangles. Each triangle is 180. So 2 times 180, or 360 degrees, is going to be the sum of the angles in any quadrilateral. In a triangle, in a pentagon, there are 3 triangles. 3 times 180. Pentagons are going to be 540 degrees. In a hexagon, there are 4 triangles. Each triangle has 180 degrees. 4 times 180 is 720. Now, of course, what we're going to want to see is there a way we could work this for 10-sided figure without having to draw in all the diagonals and then count up all the triangles? So let's look for a relationship between the number of sides and the number of triangles. The number of sides and the number of triangles. The number of sides, the number of triangles. Is there a relationship between those? Well, yes, there is. The number of triangles is equal to the number of sides minus 2. So that means the sum of all the angles is going to be the number of sides minus 2. And then we have to take that and multiply by 180. So that's the sum of all the angles. Now if we take that and apply that to different types of shapes, this first shape looks like it has a total of 8 sides. So the sum of the angles is going to be 8 minus 2, the sides minus 2, multiplied by 180. That's 6 times 180. And I believe that's 1080. Next, for a 15gon, which is just a polygon that has 15 sides, the sum of the angles is going to be 15 minus 2 times 180. It's going to be 13 times 180. And 13 times 180 is equal to 2,340. Probably use a calculator for that. And then finally for an n-gon, that's a polygon with n sides, the sum is going to equal the number of sides, which is n, take away 2, and then multiply by 180. So whatever the number of sides is, subtract 2 from it, multiply it by 180. This last statement is the formula you use to find the sum of all the angles in any type of polygon.